Friends, in this second lecture, we shall see how further that equation when the jet strikes at the 90 degrees to the plate is evolved. I read the text written in red. It is important to remember that to find the resultant force in x direction, that is the direction of jet, the velocity at point 1, that is initial velocity, and the velocity at point 2, that is the final velocity, should be in x direction only. Here, in this case, Vi, that is the initial velocity at point number 1, is velocity of jet itself. Therefore, Vi is equal to V. But Vf, that is velocity at point number 2, in x direction is 0 because the component of V2 in the direction of jet is 90 degrees to the actual velocity which is leaving the plate. Therefore, it is 0. Therefore, in the equation, force in x direction is equal to rho into A into V minus 0, and it becomes rho A V square. Therefore, finally, we can write an equation for this particular case when the jet strikes on a fixed plate normal to the plate. The force Fx is equal to rho A V square. This is the very simple equation we can get. Now we go for the actual problem solution. See, the problem is jet of diameter 2 cm strikes on a flat normal plate which is stationary with velocity 50 meter per second. Find the force acting on the plate by the jet in the direction of jet. Now first we shall draw a sketch. I have shown hatched fixed plate on which a jet strikes with velocity v. The striking point is initial point, point number 1, and the leaving point is point number 2. We can see clearly here is the velocity at point number 1 in x direction is v, but velocity at point number 2 is all in y direction. Therefore, its component in x direction should be equal to 0. So, in the initial equation, Fx is equal to mass upon time into v1 minus v2, that is initial velocity minus final velocity, comes to be rho a v minus u, that is rho a v square. Already we have seen. So, just substitute the values in this equation, that is rho is equal to 1000, area is calculated by pi by 4 d square, and velocity of the jet is 50. So it comes out to be 785 Newton. So slowly we shall go for other such cases when the plates are inclined, when plate is curved, etc. in the next lecture. Thank you.